Good morning. It's June 8, 2025. Welcome to the Cosmology discussion group. I see we have some people here. I'm going to get started. Today I'm going to talk about this book. Here's the book. You can get this on Amazon for not that much money. I guess you can download it. Tired Light, An Explanation of Redshifts in a Static Universe by Lyndon Ashmore. I'm going to kind of just briefly talk about what's in the book. I'm not going to try to go into any detail about it. The technical, he doesn't really go into technical details and any real, it doesn't go into a lot of detail, just enough to pique your interest, so to speak. Okay, I'm going to bring up my, can you all hear me?
Yes.
Yeah. Mhm.
Okay, you should see the presentation. All right. Interesting.
There. Okay.
Okay, as I mentioned earlier, the name of the book is New Tired Light, which implies that there is an old tired light. Okay, so what is tired light? It's an attempt to explain an explanation of redshifts in a static universe. Oh, that's the name of the book. Tired Light, An Explanation of Redshifts in a Static Universe by Lyndon Ashmore. And there's if you want more information, there's the web address. Proposes a new physical mechanism to explain redshift due to photon energy loss. Okay, so it's kind of a different theory of explanation of the redshift. And the key point is how do we explain photon energy loss? This came up yesterday in a discussion. The current mainstream theory explains redshift by an increase in the wavelength due to an expansion of space, but that doesn't have in it a theory of how the photons lose energy. So that's going to be addressed in the tired light theory. Okay, so the main features of the theory are it assumes a static universe. And I think that's one of the key motivations for addressing or putting forward this theory. And the redshift is caused by energy loss caused by collisions of photons with electrons in the cosmic medium. So that kind of in a nutshell is what it is attempting to do. Uh-oh. And let's see here. All right, well, I messed up rather badly.
Why is this called New Tired Light?
I just explained that. It's a new theory.
Uh, what I heard was there's nothing new about it at all.
It's a new theory. Well, why don't you wait until? All right, I'm messed up here now with the computer's not advancing the slide. Well, that was a mistake on my part.
Well, from what I read many years ago, Fritz Zwicky had arrived at the tired light theory when when Hubble's expansion was first proposed, and it was very similar to the current theory, I think.
The mechanism by which the energy loss occurs in this particular theory is different from the okay. I shouldn't have pushed the full screen
Hmm.
function on this thing. Now I can't. Oh, crap. Oh.
Close it down and start again. Can you not
That's
do
what I
that?
was thinking about doing, but that, um, all right. We're going to close her down and start again. Okay. So, it would be nice if you were a little patient about, um, oh, crap. So it won't let me, I have to close Zoom. That's
Oh,
nice.
oh,
Well, go off and even boot your system. We'll give you a few minutes. That might solve it.
All right. I guess we'll have to start over. This is June 8th, Cosmology Group meeting. My name is Harry Ricker. I'm going to share the presentation, hopefully. Yeah, I was afraid that was going to happen. So now I got the same problem that I had before.
what was it though? Because we could see the screen.
You use a large font in your slides so that what you displayed before was totally readable.
It's taking its sweet time in loading the presentation document. I don't,
So how relevant is the tired light theory, would you say?
what do you mean by how relevant?
Well, at what level would you say you agree or that there's verification for it?
That's part of the part of the discussion. I guess you'd have to read the book.
You could give me a ballpark figure, maybe.
I'm not sure what you're asking.
What is your opinion, basically, I guess?
I guess you'll have to see the presentation.
Okay. Well, I mean, oftentimes you present presentations, but you don't really readily give an opinion, which, that's cool though.
That's a bit like you, Jerry, which is fine as well.
Well, I think I give opinions. I just admit that I don't know certain things. Go to an Ian.
Okay, can we see it now? All right, let's see if we can get to the second slide. Um, Now, okay, can everybody see it? I've got the video
Yes.
on the right-hand side and it was covering up the presentation. All right, so here's the second slide. We talked about the first slide. New Tired Light is the name of this book by Lyndon Ashmore, an explanation of redshifts in a static universe. So, okay, your answer to your question is the universe is not expanding according to the tired light model. So therefore you don't have um, uh, a Big Bang origin of the universe or any issue about to explain how is that the universe is expanding there are two theories that result from that. One is the steady state theory. The other is the Big Bang theory. The steady state theory has been discredited by mainstream. I've talked about that in previous meetings. That leaves the Big Bang theory, which if you retrodict in time, retrodict means to predict backwards. And so if you predict backwards in time, if the universe is expanding, you get to a point in time where there was an origin, the universe shrank to a point, and so they claim that there was an origin of the universe. So that whole point goes away if the redshifts are not due to the expansion of the universe. Space is not expanding according to general relativity. Therefore, you don't need the expanding Big Bang model. You don't need flash origin at the beginning of time, and you have a static universe where time is forever. Space has existed and time has existed forever. That answer your question?
Who, me?
Yes.
Oh, yeah, thank you. Well, I mean, I didn't know your personal opinion, though. That's okay, though. But I would agree that time and space have always existed in some form. I mean, like, well, the universe has existed in some form, but the time and space inherently have to exist. That's my personal view.
All right. Okay, so it's called new tired light because there's a new physical mechanism to explain redshift due to photon energy loss. And I'm going to talk about that in more detail. Assume static universe and redshift caused by energy loss caused by collisions of photons with electrons in the cosmic medium. Okay, cosmic medium. All right, so here's the capitulation of the history of it. Okay, I've talked about this a couple of times before. Slipper and Hugh Mason measured spectra of nebula. At that time, they didn't know whether galaxies were inside or outside the galaxy, but they were measuring the spectrum for what are called H2 regions. You get spectral lines, and for galaxies, they were puzzling at first, but the spectral is stellar in origin, which means that the spectra resemble spectrum of a star. But then at first it was puzzling. Then they realized that the lines were shifted to the red or to lower frequencies. And then later, Hubble established that the galaxies, as we call them today, we call them external galaxies, or that they're extragalactic. Extragalactic means they're not inside of the Milky Way galaxy we reside in. Okay. And then Hubble took the data that Hugh Mason and Slipper had begun collecting and extended that and established the redshift distance relation based on his measurements of distance using the Cepheid variable stars. And so he was able to establish rough distance estimates and then created this redshift distance relation. And originally, the redshift assumed, due to the Doppler effect, which implies the galaxies are moving away from us, that in connection with the general relativity theory, when they started developing solutions to the general relativity theory for the universe as a whole, the solutions indicated that the universe was unstable and expanding, and that combined with the redshift information led to the conclusion that the universe is expanding. So those two lines of reasoning, the redshift is an observational evidence combined with the theory that predicted that the universe is expanding, that became the established conclusion. And that's heralded as one of the greatest scientific discoveries of humankind ever. It's really important to understand that part. Okay, Any questions about that? No. Okay. Okay. So the story is Zwicky first proposed tired light theory. Supposedly, there was a meeting in which Hubble and other people at the Palomar Observatory were having, and Zwicky raised his hand and offered this suggestion of tired light. And the idea sort of it's simplified by saying a sort of gravitational analogy of the Compton effect, which not really clear, but the idea is that the photons collide with electrons in the interstellar medium, and when that happens, there's a recoil effect. The electrons lose energy due to the recoil. Gain energy due to the recoil, and the photons that collide with the electrons lose energy, and that shifts their frequency to a lower frequency, and hence increases the wavelength. And over a number of these collisions, this causes the redshift to occur. And Zwicky proposed this idea in 1929. Of course, the mainstream, they'd already decided that they knew the answer because general relativity is correct, because Einstein's a genius. And so they immediately sought to refute this idea. And there's what's called spectral line broadening. That means that because when this collision occurs due to the Compton effect, the electron collides with a photon, or actually the photon collides with the electron. And this, when the recoil effect occurs, it causes the energy to spread out. The energy that's transmitted forward in a photon is spread out. Okay, it doesn't stay on the same frequency. It comes out in a range of frequencies. And this range of frequencies, called spectral line broadening, isn't observed in observations. And so that was taken as disproof of the tired light hypothesis. Okay. And I talked about that. And of course, the important thing to understand here is that this whole idea is really based on quantum theory and the energy equation E equals h nu. I'm sure you're all familiar with this equation. Is anybody not familiar with this equation?
I'm unfamiliar. I thought quantum mechanics was after this, or maybe
Well,
it was around the same time.
it came about in the 1920s, about the same time as
Oh, okay.
Hubble was discovering the distance redshift relation.
Well, how do they correlate though?
What do you mean?
How is how is quantum theory applied to this theory?
Well, because the theory is based on the quantum energy equation E equals h. Okay, and so that equation says that the nu is the frequency. Are you familiar with this? Nu, they don't use F in quantum mechanics. You have to get with the fact that they use different notation and talk about things differently. So it's E equals hf. F is the frequency of the photon. H is Planck's constant. Okay, and so this is the equation that gives you the frequency of a photon given the energy. The energy is calculated by the difference in the energy levels in an atom when it emits a photon, and they calculate that using the quantum mechanical principle. So this whole idea is really based on quantum mechanics. That's really the point I'm making there.
But that equation predates quantum mechanics and indeed special relativity. It dates to 1900, I think.
Yes, but the idea of the energy levels in an atom, okay, and that's kind of comes out of the theory of quantum mechanics. That's really my point I'm making there. So the idea is that in quantum mechanics, assuming you believe in quantum mechanics, and everybody in physics presumably does, the difference between the energy levels of an atom is what is used to calculate the E in the equation E equals HV, which gives you from the difference in the energy levels of the atom when it does a transition, you calculate the frequency using the equation E equals HF or H nu is the way the quantum mechanics people do it. And that gives you the energy of a photon. And the idea is that the energy of the whole point of this tired light idea is that it's a completely different explanation of why the frequencies are different. So back to what I was explaining, the fundamental principle in science is that you do a comparison and you establish the concept of same and different. Is it same or is it different? So for when they measured the redshift, what they did was they would have what's called a glow lamp in the laboratory, and the glow lamp would generate radiation from atoms. Okay, and then that would be imposed on the photographic spectrograph. Okay, and so what you have when you get a spectrum or a measurement, what you get is you get a measurement of the spectrum, and then next to the spectrum of the star or galaxy that you're measuring, you get spectral lines from this glow lamp, which is basically produced in the laboratory. So that allows you to compare the spectral lines from the laboratory glow lamp, and that's assumed, that's assumed to be a laboratory at rest. And then you compare that against the spectrum that you measure, and then you measure the difference in wavelength on the spectrogram. You measure the difference in wavelength, and that gives you the redshift. Anybody have any questions about that? Okay, the mainstream theory is, and I've talked about this before, the redshift is due to the expansion of space caused by time evolution of scale factor of the universe solved as a differential equation. That's a big mouthful, isn't it? Okay, so the space is expanding. Okay, and so because according to them, the space is expanding, that causes a stretching out of the spectral lines of the light that's being received from a distant galaxy. So the light is stretched out, which causes an increase in the wavelength. And that prediction is the result of solving differential equations of general relativity for what's called the scale factor. Okay. And that scale factor is found to be changing in time according to a differential equation. And you get different solutions for these differential equations based on different parameters that you assume for the universe. All right. I talked about this already. The theory implies all of space originated at a definitive origin in time as a singularity or point. And it also implies that the age of the universe is finite. And then and the redshift occurs due to dilation of space scale factor increasing with wavelength. So I talked about that. Anybody have any questions about that? Okay. Tired light motivation. All right. So why does this guy want a new theory of tired light? So we're back to the thing I talked about before. Mainstream theory does not address why or how photons lose energy. Okay, so this part isn't really clear in that mainstream doesn't, the explanation that the wavelength increases because space expands or dilates doesn't say anything about the energy of a photon. So it doesn't even address that question. So people who are advocates, or Lyndon Ashmore is advocating a new tired light, says this is a problem. This came up yesterday in the discussion. I don't know if people remember that. This is kind of the main issue or defect in the mainstream theory, which is that theory doesn't explain the a change in frequency if you believe in the quantum mechanics equation, E equals HF. According to that equation, there needs to be a change in energy for there to be a change in frequency, but there's no explanation of how the energy changes. It's just said to, the stretching of space is said to increase the wavelength. And that's the, so you've got two different explanations of the redshift. Which one is correct? So mainstream, I just said that mainstream does not address why or how photons lose energy. And then we also have what Lyndon Ashmore calls, and I find this kind of interesting. He talks about the crystal spheres. What one of the points that he makes in his book, which he brings up quite frequently, is the crystal spheres, and that's a reference to ad hoc corrections. And it's kind of, the idea was that back in the Greek astronomy, if the observations didn't agree with the theory, they just added another crystal sphere. And so he's sort of making fun of that. And so in his book, he talks about adding, he says, well, instead of calling it an ad hoc adjustment to the theory, he calls it adding an additional crystal sphere, which I find is kind of interesting. And if you're not really familiar with what a crystal sphere is, this book kind of might be puzzling to you. Then
he might be also referring to the epicycles of Ptolemy.
That's what I just said.
Same thing, maybe.
Yeah, they're the same thing.
Okay.
It's the same thing. Epicycles, crystal spheres, it's the same thing. Just another way, another phrase. That's why I think this idea of crystal spheres that he brings in is kind of, if you don't really know what he's talking about, it's kind of obscure. Then his argument is that we bring in Occam's razor, the simplest theory to explain redshift, a minimum of assumption. So he thinks that explaining the redshift due to the tired light idea is the simplest way to explain it. And that's basically his argument. It's like Occam's razor. This is the simplest way to explain it. We don't need to bring in general relativity or all these theoretical assumptions involved in general relativity and cosmological model calculations. We're just going to base our theory on observation and a very simple physical process. So I talked about this, the energy equation, E equals HV. And that's the quantum mechanics idea. So tired light idea is basically doesn't have the general relativity. It's really based on the quantum mechanic equation here, E equals HV, or E equals V being the nu is the thing. That's the frequency, E equals HF. And then he goes through in his book, he goes through well, we could assume a lot of different things are changing, and spends a lot of time talking about this. I'm not going to go into that, but he's basically goes with the assumption that H doesn't change and C don't change. Those are constants. Okay, so there's some of the assumptions that time and energy are unchanging. So there's no issue in this equation. Okay, he's assuming that everything that affects this equation is constant with time, doesn't change. Okay, which means that the spectral lines that are emitted on a distant galaxy or quasar, they have the same energy levels as the ones that are used in a laboratory as a standard for comparison. Okay, and then so based on those assumptions, so we have to have some assumptions about what is the same and what is different. Okay, so he's established that the only thing that's really going to be different is the energy, and his theory is that the energy is different because the photon loses energy in electron collisions, but the mechanism by which the energy by which this collision mechanism occurs is not the same as the Compton mechanism that Zwicky proposed, and following his proposal, they claim that was disproven by the blurring of the spectral lines. So he's proposing a mechanism that doesn't blur the spectral lines. And that's a little bit, Jerry asked about whether that's convincing or not. I'm not really particularly convinced by the mechanism that he proposes for this to happen. I don't know that it's wrong. I'm not really that familiar enough with the physics of his proposed mechanism, but we'll talk a little bit about the mechanism later. But here's the key point. Okay, in order to do this calculation or do any calculations, you have to know how many electrons are out there in intergalactic space. And he invokes the fast radio bursts, the FRBs, which we've heard about before. Okay, do people remember where we heard about the FRBs before? Well, Vadimir's talked about this on several occasions. It's an integral part of Vadimir's theory, okay, in his cosmic medium. Okay, so he's going to invoke the FRBs that, based on their observations of the FRBs, what happens is that there is a spectral broadening of the FRB spectrum. So what that means is that part of the signal, like at one frequency, the signal will arrive, and then on the lower frequency, it'll arrive at a different time. Okay, so you can compare the times at which the FRB arrives at different frequencies, and from that you can calculate a electron density, okay, of intergalactic space. But the main thing that you need to know is you need to know where the FRB is, okay, in order to do the calculation of what the density of electrons in space is. And so based on that, there's an FRB 150418, which occurred in a galaxy of a known distance. And so that was in 2015. And so taking the known distance to this galaxy where this FRB occurred, they can do the calculations and they come up with estimates of the electron density in intergalactic space. Okay, so now we'll talk about the reason for that is that's the important parameter that he uses in his calculation. The electron density of the cosmic medium. There's that word, cosmic medium, again. We've heard that word before, that phrase before. Okay. NTL does not assume the discredited Compton scattering mechanism. I've mentioned that before. And now here's the mechanism. NTL, tired light, assumes that there's an electron absorbs the photon energy and then re-emits it at a different frequency. Okay, that's not the same thing as Compton scattering. Compton scattering says that the photon hits the electron, and the electron, in recoiling, emits the radiation on a different frequency, okay, while it's recoiling, okay, and it's because the physical process is different, that the Compton effect has spectral broadening, and Lyndon Ashby claims that his mechanism, which is that there's a time delay between the absorption of the photon energy, so the electron absorbs the energy and then re-emits it later, okay, and it doesn't emit the photon. When it emits the photon, it emits it at the same frequency because the electron is not recoiling yet. That's my understanding of his physical mechanism. And I think I've said before, it's not clear to me that, I'm not 100% convinced that this is a legitimate process, but he claims it is. Okay, so as I said, NTL assumes absorption and re-emission, and energy is exchanged to electron and the emitted photon. And so it's a different process of exchange of energy. So later, after the electron emits another photon, the re-emission photon, then it recoils, and then there's another photon, and there's some other energy that's exchanged. And I find it very, you have to read his book to really understand exactly what he's talking about. I'm not going to try to explain it here. Okay, and one of the interesting aspects of this theory, which I find kind of also interesting, he claims that there's additional radiation emitted. There's a residual radiation that occurs, and that this energy goes into producing the cosmic microwave background radiation. So he's got a twofer here, and beating on the Big Bang. He's claiming that redshift is not caused by the expansion of space, and he also has an explanation of what causes the CMB. So his theory covers those two areas that could be put forward as objections. Okay. All right. What to like about the end of the new tired light theory presented in Lyndon Ashmore's book. The universe is static and eternal if NTL is correct. So people who don't like the idea that there's a beginning in time and that the universe was created at some creation event, if you don't like that, you don't feel comfortable with that, you don't believe that, this would be a theory for you. Big Bang theories are refuted. A lot of people don't like Big Bang theories. And so you can sort of take this theory as I don't believe in the Big Bang theory. I believe in tired light, and that disproves Big Bang. So you can look at it from that point of view. And of course, there at the bottom, if you're a scientist and you want to win Nobel Prizes, this opens up a new area of research. You don't have to, stick your research proposals don't have to be based on the Big Bang theory, which has it's got a lot of crystal spheres in it. So what are crystal spheres? They're ad hoc assumptions. There are lots of ad hoc assumptions in that theory. And so, dark matter, inflation, that sort of thing. We can sort of avoid all those. What not to like about the NTL? It's not verified in a laboratory experiment. That might be the biggest negative. In his book, he talks about some ways that the mechanism that he proposes could be demonstrated in a laboratory experiment. I assume that's not been done, although this book was published about 2016. So maybe it's been done, don't know. And then there's the usual claims that the mainstream has put forward. He kind of tries to negate those claims. There's things like time dilation observed in supernova. That seems kind of questionable. And he discusses this in his book. I don't really want to go into these. So there are claims in the literature, the mainstream literature, that the tired light theory doesn't work because of these reasons. And in his book, he basically presents arguments refuting these claims. They're fairly technical, so in a brief, we're almost running out of time here. So, okay, the other thing, obviously, NTL negates decades of research and it validates existing textbooks. So if you're a mainstream or astronomy professor or somebody, you don't want to have your theory kicked over and dumped into an ash can. So I would assume there'd be resistance to that. And then, of course, then there's many funding grants and research programs would be rendered obsolete. And so you can imagine a lot of people wouldn't like this idea or entertain it because their research programs would be invalidated if this theory were to be believed to be correct. Okay, so that's the end of it. We got a few minutes left here before I think, before we're done with this. Any comments or questions? I guess we got about 5 minutes.
Well, the idea of absorption um, uh, proposal for tired light is an alternative or incompatible with the Compton scattering phenomena is, I think, quite questionable. In other words, there's no reason that I can think of offhand to exclude either one as occurring. So it's not an either or. And this whole thing about a new tired light theory is really not that new at all.
Well, the reason it's called new tired light theory is because the old tired light theory was claimed to have been disproven by observations. So what you do when you propose a new tired light theory is you propose a theory that doesn't obviously lead to a refutation by the observation as claimed by the mainstream. And so the main observation that disproves tired light is the broadening of the spectral lines. And so in his theory, there is no broadening of spectral lines. And so therefore the observations can't be deduced to refute it.
Yes, that's one thing. But the mainstream seem to be saying a lot in a lot of publications. Oh, there's no known mechanism for tired light, so therefore it can be dismissed. Now, I haven't worried myself too much about the mechanism, actually. I've just deduced, if you like, a tired light system. First of all, actually, by common sense, because I think if you have electromagnetic radiation traversing large areas and distances of space, it's bound to lose energy. Otherwise, you have a perpetual motion machine. And I've also introduced something that actually Stefan mentioned yesterday. He said that he mentioned this Monty Italian and the conductivity of space. Well, I've basically adopted that, because I've expanded the Maxwell equations to include that. Well, it's actually not expanding the equations. Maxwell had that originally in his equations, and it's been, taken out approximately, vanishing. But if you include this conductivity, that's basically reducing the energy, and then you equate it by the Planck formula, and you get a decrease in frequency. But the actual mechanism is interesting. I mean, I can see why he's claiming it's a new explanation. But I think you can actually argue for a tired light without having dotted the I's and crossed the T's as regards how the mechanism works.
Okay, I'm not claiming that this is the be all and the end all. I'm just reporting on his book. Okay. And I want to try to make that clear. I'm not really, I'm giving a book report in 30 minutes. And if you want details, I'd say read his book. He also has a website. I'm assuming that the website is updated. The book is 2016, I think. I think I put that in so the book's 10 years old now. So I think a lot of things have probably changed. I just think it's an interesting idea. I think that the mainstream is dismissing the whole tired light idea. It's sort of become the derogatory, they refer to it as derogatory tired light, derogatory. They don't really want to really consider any alternatives to the establishment. Unfortunately, their established position of the Big Bang has got so many crystal spheres in it, so many ad hocs, and he talks about the ad hocs, dark matter, dark energy, inflation. He thinks, and there's a lot of, they've got a lot more parameters in their theory that they can adjust to fit the observations. So they've got lots and lots of government grant money and lots of papers being published in the journals. So there's a lot of work being done on a particular set of assumptions in the Big Bang Theory. And what's kind of happening now is that set of assumptions is being, how do I say? So we're back here. I got bit by the thing. I started pontificating, and so I apologize for that. Like I said, they want to focus on the general relativity, assuming that on the authority that Einstein's a genius, and he's given us this wonderful theory that allows us to make these wonderful predictions. And then the fact that about the same time the theory, general relativity, was applied to cosmology, they discovered the redshift. Okay, and then these two lines come together, general relativity and the model predictions of general relativity coming together with the measurements of the expansion of space, of the redshift, and the theory that it is expanding space. Those two come together and form the first two pillars of the modern theory of cosmology. And as I pointed out earlier, this is the greatest scientific discovery of the 20th century. I mean, wow, of all the discoveries, think of all the scientific achievements of the 20th century: atomic energy, the atomic bomb, quantum mechanics, all this improvement in the life of, the tremendous advance in the standard of living and the average person. This is the greatest discovery ever, and that's something that, that's a lot of propaganda there.
Correct. A lot of propaganda.
So you come along with your Fritz Wiki, and you come along with this suggestion of tired light, and that you publish a paper, and then of course the first thing everybody wants to do is say you're wrong, and so they say he's wrong, and so it's set aside, and and they proceed along with their program. And as I talked about this before, Hubble was working on his program of counting galaxies, and in attempt to figure out which one of these wonderful models that have been discovered by cosmologists Friedman and Lemaitre, but the problem with it is that these models are differential equations with parameters in them. Okay, and they have to figure out, well, what of these many, they got an infinite number of solutions for the expanding universe. Which one of them is the correct solution? Okay, and so they've been pretty much engaged in that. There's a lot of money that, you apply for government grants and get money from the government. We're discovering the true nature of the universe. Wow, that's sexy. What politician is going to vote against doing that? So
I would say that the tired light theory, as well as the Big Bang theory, would have a difficult time explaining discordant galaxies, which you had brought up recently.
yeah, I didn't put that in as a con. Like I said, I would assume that Lyndon Ashmore wouldn't. He doesn't address that in his book, and I can, that doesn't really fit into his theory. And I think what his assumption is that that's been refuted by the mainstream, and so I don't really need to address that in my book. So that's not something I need to address as an issue, but it's certainly a question that arises.
I do have a
I think
sneaking
the
suspicion
idea.
that they probably deliberately tried to dismiss this by calling it tired light. I mean, if they talked about attenuated energy light, it would sound more gravitas and maybe something to be considered. But I think how can light tire? Just dismiss it, dismiss it. That's my suspicion anyway.
Well, even with
You
light's
raise an
bombardment,
interesting.
even with light's bombardment of electrons or plasma, however, throughout the galactic area, I don't understand how that would result in a redshift.
What do you mean? You don't understand?
Why would that cause a redshift? The light traveling through plasma, electrons, and such. I don't understand the mechanics of it.
Can you understand that it might lose energy?
What type of energy, though?
Well, there is energy entrained in any electromagnetic wave. It can be worked out in terms of the electric and magnetic components.
Well, if it loses energy, why would that result in a redshift?
Oh, okay, that's what I'm asking.
Why not a blue shift?
Yeah, okay. So if you admit that it might lose energy, well, then that's one question. How does that energy relate to redshift? Well, Harry indicated how Ashmore is suggesting that by using the Planck law, which is relating E equals h nu, it's relating energy to frequency. So if energy decreases, frequency decreases. Sorry, I think your thing just went off.
Oh,
Um, so I think that the big step is. The mainstream might say, oh, it doesn't lose energy. Because if they admit that it does lose energy, well, then you're halfway to suggesting that therefore there must be a redshift. I would suggest anyway, Jerry.
It's this equation E equals HV or HF. Okay, and I'm trying to make that clear, so I'm going to reiterate it. There are the two explanations for the redshift. There's the explanation that space expands or stretching, space stretches out. And as the space stretches out while the wave is traveling from the galaxy that emitted the wave to us, that causes a change in the wavelength due to the stretching out of space. The other theory is that the photon can't have a different frequency unless it loses its energy. Its energy has to change in order for the frequency to change, according to this equation, E equals HF. And if H is a constant and doesn't change, then if the frequency is the same, then the energy is the same. Okay, you understand that? And since there's no mechanism in the mainstream theory for the energy to change, only its wavelength. Therefore, it shouldn't have a changed frequency unless it loses energy. So to explain the change in frequency, you have to explain a change in energy. Does that help you understand it?
well, uh, I don't know if anyone here accepts the theory wholeheartedly. I mean, the idea. Well, if there's anything at all to fast relative motion resulting in a redshift with the Big Bang theory, for instance, I don't think at all that it's a stretching of space. It's the objects involved. I mean, space is an empty void in my view.
Well,
I mean, does anyone accept the tired light theory like wholeheartedly, or just skeptical about it? Or I mean, I'm
well,
open to
I
it.
explain mainstream textbooks basically discount it
Yeah.
because it doesn't fit into their theory. Their theory is that the redshift is caused by the expanding of space or the dilation of space, which is in and of itself a kind of a vague idea. I mean, what does that really mean? But their space is a kind of pseudo medium. It's a metaphysical concept. It's not physics. It's kind of metaphysics. You have to sort of believe that space expands or can expand, even though what space is not really anything physics or
Yeah.
physical. It's a
Yeah.
metaphysical concept. So, that's questionable right there. So, if you don't believe in the metaphysical idea of space expanding, all right, then you've got this other idea, which is, energy has to be decreased according to the quantum mechanics equation. So there has to be a change in energy. And if we can find a mechanism that explains why the energy is changed, then that makes more sense than this stretching of metaphysical object called space.
Yeah. Well, I mean, like considering the tired light theory, if light travels through plasma or electrons or however, why doesn't that just dim its glow? Why would it result in a redshift? I don't understand.
Well, all right, I skipped over this slide. All right, let's go. One of the things he did was he um, calculated the redshift based on the distance to the corona borealis cluster, and on the assumption of the density of the cosmic medium. Now, I discussed how he used the fast radio bursts measurements to estimate the electron density in space in the cosmic medium, and then calculated this. And so he came up with a redshift for the corona borealis cluster he calculated it z equals 0.062 versus the observed z of 0.72. Okay, now your question was, how does that happen? Okay, so the theory assumes that this light wave is traveling along through space and it encounters an electron, okay, and the electron absorbs the energy of this photon that's traveling through space and starts oscillating as a result of this absorption of energy. And because the electron is now oscillating, okay, rather than just kind of moving around in space randomly, it starts oscillating. When it oscillates, it emits an energy at a different frequency than the frequency that was received or absorbed. Okay. And then, so then now there's a photon of energy that's emitted or re-emitted is the terminology. And that's at a different frequency than the frequency that was absorbed in the original process of, I don't like to use the word collision because that implies that it's a Compton scattering. So you have what's called a capture area, sort of like in antennas. Yeah, an electron has this probability, what they call probability cross section of absorption. And based on these measurements, you can come up with numbers. He comes up with numbers to do these calculations based on known things like the cross section and the frequencies and the density of electrons. And then he comes up with these calculations of what the redshift is according to his mechanism of absorption and re-emission. Okay, but it's not a straightforward, the actual mechanism of it, I think, requires some more of a knowledge and understanding of quantum mechanics. And I think that's kind of beyond my ability to explain here. I'm not an expert in this particular aspect of the physics involved. So I'm not going into it. I suggest if you want details, you read his book. or go to his website.
All right. I don't understand how a light wave, because I don't believe in photons. I don't believe in light particles personally. Though, while even if photons could exist, why would they recalibrate or cause electrons to oscillate? Why would they absorb and re-emit?
Well, that's well known. I mean, I'm a ham radio operator, and we know about that. That's pretty standard. That's what causes shortwave radio transmissions to cover long distances. The radio waves cause the electrons in the ionosphere to oscillate, and those electrons that are oscillating in the ionosphere um, that are oscillating cause the direction of the radio wave to change, and then as it goes through a distance, that radio wave is refracted back down towards Earth. So that's not a completely ridiculous idea.
Wow, I'll have to study up on that.
Um, I'm not, if I thought you were going to ask questions like this, I would have given you a quantum mechanics course. That's not the objective here, to give people quantum mechanics courses. The real point of this, of what I'm really saying here is, and I tried to make this point as clearly, and that is that the difference is that you're dealing with different physical disciplines, different paradigms in physics is really probably the best way to talk about it. You know what a paradigm is?
Yeah.
It's like a set of assumptions that's adopted to explain a physical phenomenon. Okay. And the point is that the mainstream has adopted a paradigm of general relativity. Okay. It's a general relativity paradigm. They've adopted that paradigm to explain redshift. And that paradigm makes has metaphysical ideas about time dilation and space. In this case, it's space dilation. Okay, they have this metaphysical idea about time and space. There are these metaphysical concepts. We don't know what they are. Actually, time and space are really the primary concepts of metaphysics. Roger didn't really say that in his talk about metaphysics of Newton versus Einstein, but time is this metaphysical thing. We don't really know what it is. It's not like an object that you can experiment on. It's a conceptual thing, and space is conceptual too. And that's why you have all these arguments about ether, not ether, and all that stuff in these emails. People come along, they say, I believe in an ether. I know what the ether is. It's an etherions. I'm like, there's no evidence that there's any such thing as an etherion exists. And then Franklin Hugh goes, I believe in poselectrons. There's no evidence that poselectrons exist. Those are metaphysical concepts that they thought up. Okay, well, in relativity, special relativity says, well, space and time can change to justify the idea that the velocity of light is invariant. And so therefore that means that time and space can change to explain that. Okay, and then that gets extended in general relativity. And in general relativity, you get kind of this confusing thing where instead of space contracting according to special relativity, space is dilating according to general relativity. It's all just based on metaphysical ideas and calculations and assumptions.
Well, I haven't heard of space dilation. How would that work?
That's what causes the redshift.
Space expansion.
That sounds sort of hokey.
Well, okay, that's the whole point. To some people, it sounds hokey. All right. And I made it, and by the way, I just presented it. I presented a contradiction between that and special relativity, which says space contracts. You have space contraction or length contraction. And then in general relativity, you have space dilation. That doesn't seem to, I presented it in this way to particularly bring out that what's going on here. There are two different ideas based presumably on the same basic fundamental assumptions. The fundamental assumptions are, the Lorentz transform and velocity c of being invariant. I think Stephen kind of discussed that fairly well yesterday. Okay, so anyway, I kind of got off topic here. My point is that there's this disconnect between paradigms. Okay, so I just talked about the cosmological paradigm that's adopted by mainstream, which is based on the assumptions of relativity, general relativity and special relativity. So that's the paradigm, that's the underlying idea, and they explain the redshift by a dilation of space while the wave is traveling from one galaxy to another. The space is expanding, and that causes the wavelength to become longer, and that corresponds to a change in frequency to a lower frequency, and that's called redshift because the red frequencies are lower in frequency than the higher frequencies in the optical spectrum. Okay. Tired light and new tired light is quantum mechanical type thing. His ideas are based on quantum mechanics. That's a different paradigm. Okay, his idea is the way his theory is structured. He uses quantum mechanics idea as a different paradigm from the general relativity paradigm idea. You understand that? People understand what?
Yes, we do understand. Let me do a few comments about your talk about this tight light and all this stuff. Guys, let me remind you that astronomy, cosmology, this is classical physics. Why I'm so happy right now? When we are trying to combine classical physics with quantum physics, we have all these issues. It's a very important point for me, guys. If you are in classical physics, stay with classical physics only. And I don't care what's going on with photon, with electron, because it's a quantum physics. It doesn't matter for me right now because I'm classical physicist. That's it. In classical physics, we have only wavelengths we're measuring. We don't know anything about H. We don't know anything about nu, F, whatever. It's our imaginations and we are trying to explain something. But why? Why we must go to quantum physics if we are doing classical physics? In classical physics, you have electromagnetic waves. That's it. There is a wavelength of it. That's it. What is the most important? The most important is that in Big Bang model, we have a vacuum. It's absolutely wrong. There is a cosmic medium. There is a cosmic medium with intergalactic plasma. There are no electrons and protons. There is a plasma. And Ian, absolutely right. From classical point of view, it does matter for me. If there is a plasma, there is an electroconductivity of plasma. All our conclusions we are doing for the Maxwell equations in vacuum, in free medium and all this stuff. It's absolutely wrong. You must take into account classical physics, classical electromagnetic radiations by Maxwell, and put intergalactic plasma and some other components of our cosmic medium. And only then you can solve the problems, the equations of Maxwell equations, with considering all these components of it. You see, first of all, don't mix quantum physics with classical physics. And the second point, don't do any conclusions based on Maxwell equations for vacuum, for free medium. You must take into account all the components of this medium, because there are some electrical dipoles in the dipoles in my model. There are magnetic dipoles. You must take into account all of them and stay with classical physics only. That's why, Jerry, you don't believe in photons. Photons believe, but there is no, for photons, there is no wavelengths and there is no new. It's our quantum physics understanding what does it mean photons. All these particles, all them, they have only four momenta only. That's it. And I don't know nu, I don't know ash, I don't do know that photons exist and they're moving around. And the result is quantum physics, no, classical physics, electroconductivity, magnetic properties, and all this stuff in classical physics. That's why we must stop all these Compton effects, Ash-Nu effects, and all this stuff. We don't care about it. We must not do it. It's exactly what's happening with the contemporary physics. There is a mixture of quantum physics and the classical physics. And the combination of them, it's a bullshit. Because we are trying to explain something in classical physics by quantum effects. There is absolutely wrong. There are two options. I will tell you what. There is a cosmic microwave background radiation. What does it mean, this cosmic? There is no expansion for it. No, there is only thermodynamic equilibrium, classical notion, for plasma and photons together. This is only thermodynamic equilibrium, and I don't care how it goes. I know that the intergalactic plasma exists by fast radio bursts, and I know that the photons exist, and then thermodynamic equilibrium, temperature of
How can you know that light particles exist in the form of photons, though? What experimental verification is there?
If you're talking about the photons in a regime of single photons, let me remind you the double slit effect. Double slit. Remember interference, diffraction of by double slit. If you're not looking for photons that there exist, you can see interference pattern. It's a wavelength. When you start to count each photon at each slit, you will see no interference pattern. It's exactly the point. Then when you're looking for each photon, you cannot see interference. This is a border between quantum physics and classical physics. That's why it exists. There are so named, photodiodes. You can measure each photon by this very sensitive, with a high amplification. You can see them. When I was a student many years ago, I don't want to tell how long it was ago, I counted these photons by the special electronics. Jerry, you know nothing about it. Sorry. That's why you're asking this question. I don't believe in photons. Please check all these experimental results 50 years ago, a minimum. It was already such a sensitive instrument to see each photons. And I was a student. I counted them already. There was such a technique even in Russia, in the best, by the way, physical school in Moscow at that time. But what is important, believe me, they exist. But what is important, when you're talking about classical physics, there are only ensembles of photons. I don't care about each photon. I know that they have only four momenta. That's it. What they're doing, how they're doing, how they behave themselves, I don't know, and I don't want to know, because it's classical physics. It doesn't matter for each photon. I told you many times. I told you even Jerry. One
Vladimir,
second. Jerry,
you're
one second.
speaking of photons in terms of quantum mechanics, though you reject quantum mechanics or say that you shouldn't mix it with classical physics. I mean,
Jerry,
if it's a valid theory, why not discuss it as well?
Jerry, let me explain you one more time. Three times at least for you, I explain you. Do we have atoms and molecules in air around you? Do you believe
Yeah,
in oxygen, hydrogen? There are particles. Do you believe in
sure.
them?
Yes, of course.
Okay. How do you know that they exist? How?
How do you know photons exist? Because of the wave
It's
function
exactly
collapse?
the same question. The same. I told you many times.
Okay, well,
Photons. It's the
I remember
particles for electromagnetic waves.
I went through quite a series of exchanges with Chat GPT, and you know, everyone doesn't see it as a reliable source. However, though, it said you could isolate a photon. So I kept questioning it. How can you isolate a photon? Like an actual, is it a particle? And like through a constant series of questioning, it eventually said you can capture in a cavity, and it bounces back and forth, you know. But it finally admitted that a photon is a unit of a light wave. It's just like a discrete measured unit of a light wave, that it isn't a particle at all. How could light be a particle?
Check one second. Jerry, one more time. How you can isolate one molecule of oxygen around you?
Oh, I don't know if it's possible.
No, you believe oxygen molecule does exist. Let me ask you the same question to you. How do you know?
Well, I could say the same thing to
My
you,
point, you
Vladimir.
know. Tell me, how do you know that
I could say the
each
same thing to
molecule
you.
around you exists? Nitrogen, oxygen, and all of them. How do you know? Okay, sorry, Jerry. If you are a believer in something, you cannot change your belief. I know that. Less you know, more you believe.
Actually,
It's
you can change your
exactly the
belief if you're
question.
confronted with alternate data that you recognize that, well, hey, maybe there's something else in this other point of view.
All right. Okay.
Jerry, it was many
I'm
times
gonna.
already. You don't believe because you know nothing about it. That's why. I'm very sorry. It's exactly the equation. Unless you know, more belief. It's a metaphysics. You're a metaphysicist. You're not real classical physicist.
So
I'm very
your
sorry.
personal proof of the photon results from a quantum mechanics experiment, which you deny, which you say is
Oh,
irrelevant.
there are no quantum mechanics experiments.
The
There are
double slit
classical.
experiment.
All our experiments, it's a classical physics. You can measure wavelengths only. And what we are talking about, cosmic microwave background radiation. Let me continue my small speech because always you interrupt and always you are trying to tell that you don't believe, and that's it. Then don't listen to me. Let other people to listen to me. Sorry, man. Please have
All
a
right.
respect to
All right.
my talk.
Hold on. We got 7 minutes. Try to
Okay,
keep it.
I will finish in 7 minutes if Jerry will have a patience. That's it.
All right.
Please,
Okay.
Sure.
Jerry, stop him because I cannot finish my speech. Small one.
All right. All right. Seven
Okay,
minutes.
guys, there are two options. There are two different physical phenomena. There is a cosmic microwave background radiation. How you can provide this change of the wavelengths in a cosmic microwave background radiation. There is only one way to absorb your cosmic microwave background radiation with intergalactic plasma. Stay in classical physics, take into account the electroconductivity, and you will find the change of the temperature of these photons. Temperature of photons doesn't exist. We are measuring thermoequilibrium between photons and plasma. If there is no plasma, you cannot change anything. Photons didn't interact with each other. It's well known. That's why you can change anything with photons, with any radiation. Only you have the medium around when you have your intergalactic plasma. Only then you can interact with intergalactic plasma. And as a result, you will change the wavelengths of the photons. You see the very important point. In vacuum, it doesn't exist. That's why for cosmic microwave background radiation, absorption and re-emitting, it's exactly the physical phenomena, how to explain cosmic microwave background radiation and change of its temperature in time. The second very important point is redshift and blue shifted galaxies. First of all, tight light, it's only redshift. But unfortunately, even this closest big galaxy close to Milky Way is Andromeda, and it's a blue shifted. What to do about it? It's blue shifted. What is important? Well-known physicist Gupta, about 10 years ago at least, he put in his paper that he found 8,300 galaxies blue shifted against us. You can talk about tight light, Compton effect, whatever, but the one only result, Andromeda, blue shifted, and you have no explanation for any blue shifted galaxies. The experimental result was what is important. Experimental results based on wavelengths only. There are no photons. There is none. There are wavelengths. We can measure only. Why blue shifted? You cannot put any theory, tight light, whatever, Compton effect, if you cannot explain blue shifted. There is a Doppler effect. That's it. We have no choice to explain blue shifted galaxy as Doppler shift. And Doppler is a classical physics. There is no photons, there is no Ashnews, there is nothing. There are only wavelengths.
What is your explanation of the blue shift, though?
I ask you, what is your explanation taking
I
into account tight
I
light,
personally
whatever?
don't know. I'm interested in your explanation and the redshift.
You know, and do you know what does it mean, Doppler effect?
Yeah.
You asking the question, you don't know what does it mean, Doppler effect. Sorry.
No, I'm interested in what's your alternate view as far as the blue and redshifted galaxies go.
Told you Doppler effect. And if you don't know this effect,
Oh,
what
you
can I
believe in the
tell you?
Doppler effect. So the blue
Huh?
shifted galaxies are traveling towards us.
Yes, they're moving
Oh,
towards us.
okay. I'm sorry. I didn't realize that was your view. Thank you.
Okay, no, it's exactly my point. You know, we can stay only inside of the classical physics. Classical physics doesn't matter about this physics explanation. Forget about that. Sorry, forget about them. That's it. Jerry, where are you? I missed you.
All right. Okay.
Okay, guys, if you have your questions to me, that's why. Please stay classical physicists. Talk in classical physics language. That's why Doppler effect we have for
all right.
explanation of
Okay.
moving of these galaxies. But what is important? Moving of galaxies, it doesn't mean expansion. Many times I told you, expansion, you must show me center of expansion. Where is the center of expansion? Show me this bullshit. I mean, this initial singularity. Where it is? Show
So
me.
doesn't your theory have a center as well, though, with the 40 nuclear?
Yes, there is center of expansion of the nucleus of the world in the fourth dimension. We have only stretching of our surface of this four-dimensional ball. That's why center, in the center of this ball, can we see it? No, because it's a fourth dimension. But as a result, we can see stretching of our space, human space. I don't have space. I have the cosmic medium. And I can see the change in the physical parameters of this cosmic medium as a result of this stretching. Stretching, guys. You blow up your air ball and you will see how surface changes. You see, what is the difference? There is an inflation. For time 10 to the minus 34 seconds, you increase your space up to 93 billion light years diameter. In my case, forget it. There is no this, inflation. There is increase of the distance between galaxies due to stretching, due to the stretching. There is a physical phenomena behind of it. No inflation, no. There is increase of the diameter of the four-dimensional ball, and there is a stretching of our hypersphere ball. Simple like this.
All right. We got a minute to go. All right.
If you have any questions to me, guys, ask me. But don't apply quantum physics to explain classical physics. Unfortunately, these people, standard people, they don't know even the definition of black body radiation. Black body radiation, it's a thermal equilibrium of photons with matter, and that's it. There is no any other choice, and they don't know anything about classical physics. They totally confused classical physics. They totally destroyed classical physics. That's exactly what's happening today. And I enjoyed these talks today. What does it mean when you mix quantum physics with classical physics? Please stop it. Stay classical physics because there is no quantum physics in classical physics. Sorry.
Okay. All right. We're going to be, okay. So you got my point about the difference of paradigms involved.
Of course. No.
So we're back to discussing classical physics versus quantum physics. And so I guess my question at this point would be, do you consider general relativity a part of classical physics, or I don't really consider it part of classical physics, but some people probably do.
Let me tell you, as for cosmology, of course, it's classical physics. As for the general relativity, it's mathematics only. I'm very sorry. There is no classical physics inside of these equations. Even space-time, it's a geometry. It is not the real physics. Guys, what Einstein done, I told you already, I referred to some point, I do like it very much. Einstein delayed, postponed classical physics at least for 100 years. We must come back 100 years before him, because all the physics, classical physics was done before these great equations. Equations means mathematics only. Because in these equations, for vacuum, there is no vacuum. And everybody knows right now there is none. That's why all this, logic of these equations absolutely wrong. And space-time, let me ask you the question. Space-time, there is an inflation. Space inflated. But what is going on with time? Because there is no separate space and time at the same time. They calculated time 10 to the minus 34 seconds, and at the same time, space changed up to 93 billion light years diameter. How they combined with each other? What was the inflation for time? I don't understand it. Time stayed as an independent value, independent physical parameter, and space inflated to 93 billion light years. What's the everything from the beginning absolutely wrong? It's no common sense even. There is no, they named it four-dimensional space-time. They don't understand what is it for manifold and what is a four-dimensional. Four-dimensional should be four spatial dimensions, but there is no. And the fourth so-named dimension for them, it is a complex unit, IC2. It's a mathematics only. It's a mathematics. It's not physics at all, guys. Even the definition, it's a four manifold. It's not four dimensional. All their notions are absolutely wrong. They're not qualified classical physics at all. They don't know anything about the definitions of classical physics. That's why what's happening right now with physics. Why I'm so excited about you guys. What is going on around? We're in a crazy house of so-named quantum physics, classical physics. I don't know. I want to recover classical physics. It's exactly my point, what I'm trying to do right now.
Okay. All right. Anybody
Can
have any?
propose? I'm sorry. Can I propose another point of our discussion today? Because
All right, let me
yesterday,
just interrupt here. Okay, so your point is that what we have is this kind of a mishmash of paradigms, I would call them. So you have like a quantum mechanic paradigm, and you have classical physics paradigms, and I would submit that you have that relativity is a completely different paradigm. So I would separate relativity and general relativity from classical physics because it's a completely different metaphysical idea behind it.
metaphysical, you're absolutely right. Metaphysical, because special relativity based on vacuum and constant c, that is a speed of light. I don't understand speed of light at all. First of all, what is the definition of light? I know electromagnetic radiation, radio waves, whatever. The speed of light, I don't know what does it mean. And there is no vacuum, there is no speed of light. There is only mathematics in special relativity and general relativity. That's it. It's not physics. It's a playing with mathematical equations. That's it. That's why I
Yes.
don't know. I'm sorry. I don't know what does it mean special relativity, because there is no vacuum. There is no special relativity. And there is no vacuum, we know for sure from experimental result. Microwave background radiation, intergalactic plasma, all these parameters we measured by classical physics. There is no vacuum at all.
Well, okay. As far as a vacuum goes, I guess a true vacuum doesn't exist as far as we know of. However, though, with Einstein's general relativity, he suggests the curvature of space-time, which suggests that space is a physical phenomenon. I mean, how could there be a curvature if it wasn't something physical?
Yeah,
Ask
that's
them,
where you
not
get to.
me. I am against all this bullshit, and you're asking me about this bullshit.
Oh, I
Please
Okay,
ask
disagree with it as
them.
well, Vladimir.
hold on,
Why are you asking me?
Jerry. The answer is
I'm just simply telling you that general relativity is different that way. As far as the vacuum goes with special relativity, I agree with you, Vladimir.
Okay, thank you so much. It's exactly my point right now. So you are agreeing. Guys, let's stop this one because it's clear for me. I hope I try to be clear for you too, to explain what's going on. Don't mix one branch of physics with another one. Stay inside of one of them with classical physicists. What is important? We are in basis of in field of the cosmology, astronomy, all of them classical physics. That's why let's stay with experiments, with theories inside of classical physics. That's it.
The
Vladimir,
distinction I use as a working hypothesis, because I know in the texts, general and special relativity are frequently included as classical physics, and the only thing that's non-classical is quantum. But my working hypothesis is that the theories which result in paradoxes and apparent contradiction of Grecian logic, I call them modern physics, and everything else I call classical physics. And these modern physical theories developed at the beginning of the 20th century. So, according to my working hypothesis, which I just use personally, I take special and general relativity to be non-classical. But that's just a working hypothesis.
okay.
Yes, yes.
So you would say that relativity and that stuff is not classical physics. I tend to
Yeah,
agree with that.
No,
So
it is not.
well, you can't agree with that.
you say it's not, but and I say it's not, and Harry says it's not. But these are working hypotheses because the I think the majority mainstream texts say they are.
Right. That's because, but
That's why.
yeah, to me the issue boils down to what Roger was talking about. What was it 2 weeks ago? The metaphysical assumptions in Newtonian physics, which I take to be classical physics, are different, and that's why I tend to think of them as different. I don't think of relativity as being in the same category as classical physics because the metaphysical ideas are completely antithetical to the Newtonian classical physics. So perhaps if we add Newtonian classical physics, we can separate them out. I understand your point about mixing up the paradigms, and that's what I think what Lyndon Ashmore is saying essentially is he's saying that this paradigm of general relativity and mainstream cosmology isn't really that consistent with quantum mechanics because of that equation, um, energy equation. That energy equation doesn't work in quantum mechanics. I mean, in general relativity in that area. So they have a different idea. Space and time have to change somehow. There has to be gravitational effect or something to cause the wavelength to change. And if you're quantum mechanics person, you say, well, how is this changing a photon's frequency? He sees a disconnect there. That's his point, I think. He doesn't like the idea of redshift because he goes, where is the energy going to? What's happening to the energy of a photon?
Well, to me, that's a more fundamental question than the description of the mechanism. Whether it's a quasi-Compton effect or whether it's a re-emission. The fundamental conception, which can be derived through classical electromagnetic theory and Maxwell's theories and so on. Once you include this dissipation conductivity of outer space. Now, Jerry a while ago said, well, maybe there's nothing out there. It's just, well, if there's nothing out there, well, then you would find it very difficult to explain how there would be a dissipation of the energy. But if there's something there, if there's a medium, if there's an ether, if there's a plasma, whatever you want to call it, well, then there must be some dissipation. The mechanism is subject to debate. I'm not sure if I'd accept Ashmore's explanation. I mean, it's quite interesting. I must look into it in more detail. But whether I accept it or not, I still believe in tired light, and I believe it's been established theoretically. And the theoretical, the theories on which we haven't validated the mechanism, but the theories on which it is formulated have been validated through experiment, namely classical electromagnetic theory.
Let me ask you the question. What about blue shifted thousands and thousands galaxies? What's the correlation between tired light and blue shifted galaxies?
Well, I would provisionally say that I know about the Andromeda galaxy, which is blue shifted.
Even one case is enough. What about Andromeda? How you explain Andromeda from tight light mechanism?
That's right. Ab uno disce omnes, as Virgil says. From one example, you can deduce the whole. Well, provisionally,
they don't have to be the same.
I would say that
you can have a Doppler shift for Andromeda that doesn't apply to cosmological redshift.
Yeah, that's what I was going to say, Jim, as well.
Okay, sorry.
No, it's fine. I'm glad you agree. Provisionally, I was going to say that I take Andromeda as a working hypothesis to be moving towards us, and I've no problem with that.
What about 8,300 galaxies blue shifted that found by Gupta more than 10 years ago?
The cosmological redshift doesn't take over for many millions of light years.
I don't care about any millions of light years.
You're going to have
talking
Doppler
about
shift within a galaxy.
Galaxies.
That's how they measure
and I
rotation.
don't know where they are. I know that there is some blue shifted. How about tight light for all of them? Not only Andromeda.
We're not talking about one mechanism. There can be multiple. I mean, our hypothesized intrinsic redshift. Maybe.
1 second. Redshift intrinsic.
But there doesn't have to be
matter.
one, is my point. And Ian's point.
How to gain the energy for photons from some other galaxies, Andromeda, supposedly. Where
it's a Doppler shift. It has nothing to do with the Cosmo redshift. It's a different mechanism.
Energy from. Let me ask you the question. For blue shifted galaxies, you must get some energy. What is the mechanism of this and where is this energy from? Where?
Well, if we talk about the loss of energy resulting in a redshift, it does not necessarily mean that we use the same mechanism to explain blue shift. That's possible. We don't necessarily explain it. And by the way, I was most interested, Vladimir, in your enunciation of these myriad examples of blue shifted galaxies, because the sort of information I've read, well, I must confess it's mainstream, but they seem to say no, it's only a very exceptional, and they talk about Andromeda, the nearest one. That they talk about the vast number of galaxies that we see are redshifted, and that's the end of it.
Well,
Yeah, cosmological redshift does not happen within a cluster. The cluster could be redshifted by a lot, but within that cluster, there's no cosmological expansion of space happening, right? So it's a different situation.
well, how
To
far away
give you
is
a very good
how far
example,
away is
guys.
the Andromeda galaxy though? Because if it's
It's the
blue
closest
shifted
one.
and
It's only
if it's
3
caused by
million.
relative velocity, it would seem to be moving very fast towards us. So
It
how long
is.
until it
I mean
reaches us?
that's what I don't dispute that it is. It's only 3 million light years away.
Yeah. So the
It's the
question
Okay.
is,
closest, the
are all
closest
these?
major galaxy.
Vladimir might be able to answer this. Are all these pieces
You know,
of
within
blue
our
shifted
cluster, there's no
galaxies, are
cosmological
they far from
expansion.
us?
I'm sorry.
Because it appears that maybe only the near ones are blue shifted.
Yeah, and it's within our local cluster, and nobody's nobody's claiming that there's any cosmological expansion of space within our cluster.
That's one. Let me
That's one.
tell
That's
you
one of the
this.
problems of the
Let me explain
expansion
you
of
the
space
story,
mode because
guys.
they limit it to only between only when you have uh, billions of light years uh, away that cosmological expansion occurs. Not even within superclusters.
Guys, look, let me continue, guys. I will give you a very good example and you will see what does it mean. What is important in my theory, there is no blue shifted, red shifted. I cut it because there is no meaning for it. Let me tell you about the solar system. We have a solar system. All our planets moving around. If we will measure the distance between us and Mars, us and Venus, sometime you will have that Venus going out from us. We can measure it. Sometimes it's going to us. Mars, the same story. All the planets moving around our sun, they have in movement. Sometimes they are going to us, sometimes they are going out us. There is an expansion of space. No, there is a solar system, and there is a movement of planets around this center of our solar system, sun. The same story, guys, with our galaxies. We have Laniakea supercluster. 100,000 galaxies around the center of this Laniakea cluster, supercluster. And what is important? Some galaxies, like planets, moving to us, some of them going out of us, because everything depends on their movement around the center of Laniakea supercluster. It's a very good example to tell you that based blue shifted and red shift, we cannot tell anything about the expansion. There is no expansion. There is a movement of different, galaxies around center of that galaxy, of the supercluster. That's it. Guys, let's stop talking about blue shifted and red shifted because there is no meaning behind of them. The meaning is only in Big Bang model. Why? All of them started from one point and going all around. That's why redshifting. But in my case, we have superclusters, 100,000 galaxies moving around center of galaxy, and everything depends how they're moving against each other. Simple like this. There is no meaning for this. There is no meaning. And you cannot tell any conclusion about expansion of our space. The most important, I don't understand even word expansion of our voice. There is a practical in infinite space, 93 billion light years. What does it mean inside of these 93 billion years? Expansion. I don't understand it. Expansion, you can show me, first of all, central expansion, and it should be something finite. Only then you can tell about this. Only then. That's why we're talking about red shift, blue shift. There is no meaning for these parameters at all. I'm sorry. And I told you about this solar system. Please always have something simple for you and try to understand if they are moving around some center, they can go back, forth, further, closer, and everything depends on if their interaction with sizes and with dimensions. No expansion at all. There is only movement around the center. It's simple as this. And
Well,
I've done this explanation.
I don't mean to defend the Big Bang Theory per se. However, though, I don't think that they think it's possible to determine the center. Though, however, they think that relative velocity of galaxies, that the redshift determines that, and even if even if a center can't be located. Also, you often mention blue shifted galaxies, though, Vladimir. Are these nearby, most of them? Because Jim brought up an interesting point as far as like galaxy clusters and even yourself. I don't know if that was your point, Vladimir.
Very simple, There are blue shifted galaxies. Where they are, I don't know. Because everything depends on our movement against our Earth, against our solar system. They're moving to us or they're moving out of us. That's it. I don't know, guys. It's a Doppler effect. And Doppler effect means movement together, attraction, dissipation, and whatever. Simple like this. Guys, we put so much time already on this very important issue about redshift, blue shifted, tight light, and all this stuff. And unfortunately, there is not so much meaning for us. Meaning, because moving around one supercluster, Laniaki, it's well known. It's proved already at least 10 years ago. That's why, how to explain it? Some galaxy and Andromeda, it's moving to us not because there is attraction or something like this. No, because as a planet, it is to us accordingly. That's it, simple as this. They have the initial velocity, they have their orbit, and they are moving to us like planets around solar system, in our solar system, around sun. Guys, simple, classical physics, it's simple, it's common sense must be.
Well, that still doesn't explain why they're moving towards us. I mean, it's understandable that within the orbit around the sun.
What he's saying is that there's the all these galaxies are moving in different directions. It's like we're just in this mixed master machine of galaxies and super galaxies and clusters moving around in different directions. That's what he's saying, I think.
Yes, you're absolutely right. Absolutely. Guys, there are at least 1,000, maybe 10,000, these superclusters, big one. And our universe, our world, there is different superclusters in different places. They even appeared in different time. That's why Hubble, where they're measuring with different galaxies, there is no meaning at all. Even Hubble parameter must be measured only on a microwave background radiation data, because cosmic medium, it's our basis, it's our medium. All the physical component, all the physical equations valid for cosmic medium only. And we don't care about all these galaxies. Hubble parameter must be measured, and it is measured. And I calculated it 12 years ago. It's exactly what they measured 10 years after me. 10 years passed, and at last they told it must be measured against cosmic microwave background. This is a classical physics because we have a homogeneous, isotropic cosmic medium. We can rely on it. There is no questions about it. And these different galaxies, different superclasses in different directions, different, they're anisotropic. They're not isotropic. We cannot rely on them. Let me remind you that in the galaxies, we have only 2.4% of our matter. All the matter, we don't know about anything in frames of Big Bang model. 2.4% of our visible matter in galaxies, and we are trying to build new theory based on 2.4% energy and 2.4% matter. How come? Physics works differently. You can neglect with 2.4%. You must build something on 100%. This is my point. Guys, let's stop it because many times I repeated the same, and I hopefully this time I try to explain you in the simplest way. But what is important, and we talked yesterday with Ian about the yesterday's talk about new theory of gravitation. Let's talk about the yesterday's talk, yesterday presentation. What is your understanding of his point of a new theory of gravitation? Please, let's have some opinion about. And I promised Ian that tomorrow we will talk about the gravitation. What is new in his theory? Please, who saw him? Who watched him? I watched him. I wanted to tell something, but it was too much. And I promised Ian to raise this question today at your Harry meeting. Remember,
All
Ian, we talked with
All
you.
right, so you want to change the topic a bit. Okay.
Yes.
Does anybody want to have any issues to say to close the topic of tired light? Okay, so we can close the topic of tired light, and I'll answer your question about the presentation given by Stephen Gift.
Yes.
I didn't understand, essentially, I didn't understand what the new theory of gravity was talking about. I didn't really see there was a new theory of gravity. It just seemed to me like he was talking about. I didn't see a new theory. I didn't understand what new theory he was talking about if he had a new theory. So I was left totally mystified. So that's my comment on that. And anybody wants to dive in, you're welcome.
Well, he uses the constants of C and capital G, and unless you can derive the observed values for G, capital G, you don't have a new theory based upon first principles, period.
Anybody else want to weigh in?
I don't understand either. And I didn't understand his new theory of gravity yesterday. By the way, it was one more time mixture of graviton with spin instead of spin 2. And I don't hear anything about it. Why you put spin 0? How it helps? You see,
Yeah.
one more time, mixture of quantum physics with classical physics. One more time. But he took my understanding. Sorry. Then he took a well-known wave equations with D'Alembert and all this stuff. There is nothing new. Where they use theory of gravitation, theory, why sun attract our Earth. I don't understand. I didn't understand all his, theory. I tried to do it, but I could not, as you, Harry. That's why I didn't share my opinion yesterday, because I didn't understand anything. What's new? What is his theory? What is about? I don't know. Ian, maybe you can understand. You understood. Maybe you can explain what we heard yesterday, because I didn't. I did not.
Yeah.
That's why I didn't want to share my opinion with you and him.
Okay. Well, I mean, he could easily have entitled his talk an extension of classical gravitational theory, with some credence. Maybe he's sort of extrapolating a bit by saying it's a completely new theory. I mean, he was like expanding the system into this D'Alembertian, where you have the wave equation with all the time parameter as well as the space parameters. And then he was deriving the same equations for perihelion shift and for deflection of rays of light as actually general relativity, or even before that, the Gerber equation. He was deriving the same equation based on the finite speed of gravitational interaction. And so whether that's a completely new theory or whether it's just an expansion, I think Stefan has the ability to take existing theories and maybe go a bit further. Now, some of those ideas were questioned by, say, Dennis Allen, and maybe even myself slightly, although I didn't want to go into too much as host. But he was saying, he contradicted Stefan in saying that he accepted the hypothesis of the speed of gravity being the same as the speed of light, and maybe he was getting results which were acceptable, because what he wanted to do on his own admission is, he said, look, the mainstream say that these tests, A, B, C, the Shapiro delay, and all these 4 tests or 5 tests, uh, are confirmed by general relativity. So his theory must confirm those tests as well. And
Yeah, that was kind of clear, but I didn't understand what his theory was. What was his theory?
It's exactly my point. What is his
Yeah,
theory? He
yeah, I
took
know.
standard
Who am I
wave
to say? His
equation.
theory was no more than an extension of classical theory to give the same results as many of the results that are accepted nowadays. So, for example,
right.
Gerber's equation for perihelion shift of this deficit, it comes out of his equations. Well, maybe it isn't essentially different from Gerber's derivation, but what he was doing is he was having like a 4-dimensional wave equation, based on a scalar potential, gravitational potential, which would travel at the speed of light. And if you plug that in, you probably do get the same equations. Well, maybe it would have been fairer to say it's an extension of classical ideas. He's just put in 1 or 2 further ideas. But Dennis Allen actually was in correspondence with him, and he sent me a copy of the letter a bit further, saying that there is a reason um, uh, to look at um, the vector potential as distinct from the scalar potential. And he actually credited me with giving the analogy in electromagnetic theory, where the scalar potential, the scalar field would be almost instantaneously established, whereas the vector potential, which governs the speed of transmission of the electromagnetic radiation, would be a finite amount, c. So you could usefully apply those criteria to gravity. And Stefan just said, well, those are all very good ideas, and he's going to look into them. Because I think, to be fair to Stefan, I genuinely believe, I said it to be polite, but I genuinely believe that he has a very open mind and he's willing to look at all these avenues. But he tends to concentrate on one aspect himself, which he's delved into in great detail. So I don't know if I've answered your question as to why it's a totally new theory. Maybe it's really an extension of existing theory, and he doesn't take in the modern ideas.
All right, we got 7 minutes. Go ahead, Vladimir.
Let me ask you the question. One more time, he talked about equations only, but he claimed a new mechanism of gravitation. What is the mechanism?
Yeah,
Mechanism is not equations.
that was what I didn't quite get.
No,
I didn't
what is the
understand the
mechanism?
spin 0 versus spin 2,
Yeah.
and how
But
that.
there is no spin theory. He didn't talk about spin 0 or 2, nothing. That's why it's a mathematics. By the way, this D'Alembertian, it's from the Maxwell equations. Everybody knows from studentship. It's a standard wave equation. That's it. Simple like this. Let me tell you, unfortunately, people, they don't know another great physicist, Heaviside. He transferred Newton's law and all this stuff into gravito-magnetic field. And he told we must take into account not only masses of our planets around the sun, we must take into account mass currents. The approach to gravitation must be based on electrogravitomagnetism. He named Heaviside in this way. He was a great scientist. He found the option between electromagnetic waves and gravitomagnetic waves. You see what I mean? We forgot all these great genius scientists. Heaviside was one of them.
Well, it's
That's why,
the ideal.
even to explain,
It's worshiping Einstein, so they're stuck on
oh,
worshiping Einstein.
forget about Einstein. It's a mathematics only.
Well,
I will tell
but
you
my
why.
point is they're
Because
stuck on that. That's their only
Yeah.
paradigm. They're stuck on that paradigm.
I know, but
Einstein.
it's
Another example
mathematics.
more recently would be J.P. Wesley, who's done a lot of work in integrating these two. And it's totally contrary to the mainstream ideas.
What is important, even dark matter, you don't need to explain all this behavior of galaxies based on dark matter. On the contrary, I refer to this work of some guy, I forgot his name, it doesn't matter. He showed that if you will go with a standard gravity-magnetic field theory, you must take into account these mass currents, and then you don't need the dark matter to hold these all the units of the planets or galaxies together. Instead of dark matter, go to Heaviside. 130 years ago, he played Pluto already his theory. That's why I don't need new gravito-magnetic field or mean theory. I need only to jump from Newtonian law, Kepler law, and all this stuff to this physical explanation what's going on with all our planets, galaxies moving around their centers. Please take into account not only masses, but mass currents too.
But
All
perhaps a
right.
new derivation which doesn't exist in existing theories would be the Bode's law that he talked about. Now, he did give credit to Beckmann, who probably got this essentially the same thing. But this business where you have an equation for the Titius Bode's law, which, as I point out, is related to harmonic series and is related to the Euler constant, and that was something he hadn't looked at. But he has this factor in, and the mainstream. He was right in saying the mainstream not only cannot explain it because it's not explained by general relativity, but they don't even mention it. In any books that I've looked at, they said, "Oh, it's probably just a coincidence. We've no explanation for it at all." So that's one new thing, perhaps.
All right. We got 3 minutes.
Hey guys, that's why, sorry, Harry, I misunderstood. I didn't understand what is talked about, what is new about. What is one more time mixture between classical physics and quantum physics? Don't do it, guys. Stay inside of the frames of classical physics only.
All
Well,
right.
he's contravened your advice there because he said, "Oh, I explained this by a hypothetical particle called the graviton, which, contrary to a quantum orthodoxy, which says it has a spin of 2, I say it's a spin of 0, and that gives my equations." So that's how he's trying to integrate a quantum with classical. And I know that's a red rag to a bull to you, but that's what he claimed.
Okay.
Let me just comment. I didn't really understand what the Titus Bode law thing was about. And I have to admit, I'm going to be fair I was falling asleep at this point.
I did not. I
I think
tried
I
to
fell
understand
asleep through
something,
part of it.
and I could not. I'm
It's
sorry.
it's a pattern of where the orbits of the planets appear.
Yeah, but why? How do you predict it? I mean, he claims he's predicting the.
The
And I'm
distance.
going like,
Well,
how does that?
Beckman
How does your theory?
Beckman proposed that this gravitate magneto-gravitational force that um, actually
Yeah, but
defines
I didn't see any
defines points
mechanism.
points
I didn't
in the
see any
in
mechanism
orbits.
for saying a
Sorry?
planet is here and not here. I didn't. Anyway, okay, we're going to finish up here. We got about a minute. I want to thank everybody. Does anybody have any suggestions for topics in the future? Anybody want to make a presentation for a topic in the future, like next week?
But
Okay.
I might mention that I think I'm going to have to skip the Saturday after next because I've had a back out. It's been cancelled and postponed for much later. So just to give you advice that if you want to hold something on a Saturday, it won't be next Saturday, it'll be the following Saturday.
All
You
right.
might give some thought about that.
Okay.
Only one comment, Harry. Please change my wrong email address in your letters. That's why I didn't get any invitation from you. Yesterday, I
I
asked
changed your
Ian
email.
to send me invitation.
Okay, you're not
It's my
getting.
fault.
Okay, you're not getting the emails. Okay,
It's
I
wrong.
changed the address. I'll check to make sure that I did
I
it.
think there was a misprint in it because I forwarded to Vladimir yesterday, and I
Yes,
think you
yes.
might have had V dot or something.
Yes, additional V, cut additional V at the end of my family name.
Yeah.
Please, that's it. I ask Ian, what's going on? Why I couldn't get my invitations from you, Harry? He sent me. That's why I'm with you today, guys. Yeah.